Hi students, so welcome back to my channel. So SADHIK-Physics. So you can learn the physics very easily from this one, no? Right? So while you are watching this my YouTube videos, no? So please take one note and try to copy it whatever I am teaching, no? So that you can make it like a one proper notes. So my channel will help you to understand physics very easily up to NEET and IIT-JEE level, and even sometimes I am discussing advanced question also. So once this level is over, we will go for advanced level questions, no, advanced topic. First of all, you should be very strong in basic level. That's why we are making these videos, no, go through it. So these topics are very sufficient up to JEE mains level onto this, right? So now let us see, today's I will discuss, no, Debroglie matter waves, no, right? So what is this Debroglie matter waves, no, and how the questions will be asked and how to learn the physics also will discuss in this chapter, no, right? And this concept is very important for JEE mains, NEET and advanced level, no, compulsory you can expect the question. So you should be very thorough. I think you already studied some more topics, no. So, but let us discuss the methods and different model questions, no, we will discuss in this class, no, right? So thank you. Please subscribe to my channel, no, then we will go for our today's topic. So first of all, let us see what is Debroglie matter waves, no. Matter waves, right? Debroglie matter waves now. So you know that actually here this is one type of wave. Already we know that mechanical waves, electromagnetic waves, mechanical waves means which requires medium for its propagation, no. Electromagnetic waves which does not require like light and all this one, no. So matter waves means what? The wave associated with a matter itself. That means if any time matter is moving, so it will move in the form of like a wave, right? Actually this concept has come so to explain about the light onto this one now, right? Why? Because light is showing some behavior like a wave nature by interference, diffraction, polarization. These all are the wave properties of the light. And light is also showing one property, that is particle nature like photoelectric effect and all this one now. Like light is showing what? So light here has a both, no, light has a one is wave and light is having the particle. Particle we know that it is photon, it is then explained onto this one, no. Wave therefore interference, diffraction and polarization, no, this all be showing by the light onto this. Light is in the form of a wave and light is also showing photoelectric effect, Crompton effect, no. So therefore light is behaving like a particle nature, no. So wave means like wavelength, like frequency, velocity of the wave, like that we will study. Particle means what? We will study mass, velocity, momentum, kinetic energy, like that. So it's a two different scenarios. But there should be compulsory one interlinked concept should be there between the wave and particle onto this. So therefore it was given by our Debroglie. He says that matter waves, no, that is while a matter is moving, it will move in the form of like a wave. Even I am moving, I will move in the form of like a wave. If an aeroplane is going, it will go in the form of like a wave. But we cannot visualize it now, right? So why? We will see that concept, no. So why we cannot visualize it now? We will see, right? So because Debroglie matter waves, no, is tells that if a matter is moving, it will move in the form of like a, so matter, if it is a matter move, so it will move in the form of wave. The wavelength of this wave, it will be given as wavelength, it will be given as lambda, it will be equal to h by so mv, that is h by momentum, right? Or therefore here h is nothing but a Planck's constant, no, therefore here you can write it as like a h by p. Wavelength of the matter wave so was defined in this way. How it is came, no, you know, therefore photon, no, E is equals to photon hc by lambda. So here energy for the matter, no, therefore mc square. So energy both are same only, so therefore just you can take it onto this mc square, it will be hc by lambda, 1c get cancel out, no, lambda is equals to h by mc. Therefore here wavelength of the light photon, it is given as h by mass of the photon into photon will travel with the speed of the light, no, mass into velocity. Mass into velocity is nothing but a momentum. So therefore de Broglie wavelength, it was nothing but defined as h by mv now, right. So this is h by p. You know that h is what? H is nothing but a Planck's constant. H is nothing but what? Planck's constant. This constant value is very smaller, no, therefore this value is 6.6 into 10 to the power of minus 34, so joule second. So this is your value of h. Clear? So therefore h is equals to 6.6 into 10 to the power of minus 34 joule second. This is the value of the Planck's constant onto this, right. So 10 to the power of minus 34, this is already numerator is smaller. If anything denominator is larger, no, it will give still more smaller. You are understanding? So that's why, so here momentum, any momentum, small momentum is there. Also this h value is very smaller, no, therefore that wavelength will be very minute, no, so that you cannot able to visualize it. So that's why, so this de Broglie wavelength, it will be associated with a very low mass particles or very low mass particles, no, like the photon and electrons only. Even proton also it will be having slightly higher mass, no. So therefore it cannot be visualized. Only for the electron level we can see it, no, and photon level. So in this way, so therefore de Broglie gave the relation between the wave and the particle nature by this equation now. Clear? Now let us see. So we'll study this one now. Therefore this equation, let us see now. So lambda is equals to h by mv, you know that h by p. So still we can write down some more formulas now. These formulas are very important now. Listen carefully. So momentum and kinetic energy relation now. How? So you know that momentum can be written as like a, so h by square root of 2m into kinetic energy. Clear? So even kinetic energy is there now. Therefore to accelerate the charges, no, you have to create one potential difference, no. Therefore h by square root of 2m into kinetic energy is nothing but can be written as q into v. V is nothing but a potential difference, or can be written as h by, so in terms of temperature now. Therefore here square root of 2m into kinetic energy is nothing but 3 by 2 kT. So therefore you can rewrite it as, therefore you can simplify it, no. So here, so cancel the 2, therefore it will be nothing but a 3m kT. K is nothing but a Boltzmann constant. So these are the formulas for our de Broglie matter waves or wavelength of the de Broglie matter waves. Clear? I am telling you, so from this formula you can expect compulsory one question in any one of the any examinations, no, like NEET, JEE, IIT-Advance, no, they may expect the question based on these formulas, right. Now let us see one simple concept, no. Therefore how many formulas are there? No, there are 5 or 6 formulas are there, no. So how many problems, how many ways the questions can be asked? You know these formulas, no, it is written here, no. So how many ways the questions can be asked? Questions can be framed. Actually the students know they should understand in this way only. Therefore the given formula, substituting, getting the answer, that is not the correct way of learning. So the student has to think that how many ways the questions can be framed onto this. So really if you are seeing this video, please pause this one now, then just type it how many questions you can frame, right. Just an average, some number, right, random number, no, just you give it in the comment section now, right. You will be surprising that therefore that many questions can be created onto this. In that way you have to think it, right. Actual real thing is what? Real thing of learning is in this only. Mostly the students know they feel difficulty in physics, no, because of due to this reason, right. So what they will do, they will think that only one formula substitution you will get the answer, we got the physics. No, but in the competitive examination they will ask in different way, different method, right. So the student has to think how many possible ways the question can be framed. Even by using one formula, you try to create some questions. Then your brain will think so many ways how I can make it. So in this way, if you really learn, no, definitely the physics will be wonderful subject, no. So you will enjoy like anything onto this. Clear? So mostly the students will not think onto this one, no. That's why they feel it is difficult, no. But please, my suggestion is what? If any one formula is there, you think that how many possible ways the questions can be framed onto this. Clear? Right? So, right, if you really like this or no, just please comment it, no, right. I will show some sample of this type of questions, no. So, they may give mass and velocity, they may ask you wavelength, very simple one, no. Momentum they can give like this, no. Kinetic energy, mass they can give, Q and V they will give, and temperature they will give, right, like that, no. So, this is some 6 type of questions, no. What they will do? They will change the velocity. Therefore, how much percentage change in the wavelength they will ask. Change the kinetic energy, percentage change in the kinetic energy, percentage change in the wavelength they can ask, no. Percentage change in the temperature they will ask. They will ask, no, percentage change in the temperature they will give. They will ask percentage change in the Debroglie wave, like percentages they will ask. They may ask you the graphs related to this one. How the graphs will be there? It is inversely proportional graph, momentum inversely proportional graph. Therefore, wavelength is inversely proportional to the velocity, wavelength is inversely proportional to the momentum, wavelength is inversely proportional to the root kinetic energy. So, wavelength is inversely proportional to the square root of V. So, wavelength is inversely proportional to square root of T. So, therefore, inversely proportional graph, no, you can rewrite it as like a wavelength and momentum or velocity, no, how the graph it will be, it is inversely proportional. No. Clear? So, in this way, they may ask you the graph. Or in this graph only, they may ask you one more question like this, here, therefore, wavelength, so into P, so wavelength into P, so into wavelength. Therefore, what will be the graph? You know that wavelength into P, you can rewrite it as wavelength into P, it is nothing but a H. H is nothing but a Planck's constant, no? Planck's constant means what? Therefore, the graph can be a straight line. Clear? So, therefore, they may, right, so many ways they can ask onto this one, no? Right? One more concept, no? Here, velocity is there, this velocity is there, no? So, this calculation of the velocity, total kinematics can be applicable here. You can apply the V is equals to U plus AT, V square minus U square is equals to 2AS, how you calculated now, right? Here, one more, momentum is there, no? Momentum means again force, again they may ask you because momentum is nothing but creates like a change in momentum is nothing but creates force, and they may ask you collisions, right, explosions onto this one, no. I already discussed one concept, one video is there, so please go through it, that one, no. So, I will keep it in the I button, right. Momentum, therefore, collision conservation of linear momentum, no. So, they may ask you all collision concept, no, it will come here, all kinematics concepts, no, it will come here, no. Even not only in the kinematics equation, no, velocity can be calculated even in magnetic field. If a charged particle is going in a magnetic field having velocity, even if a charged particle is going in electric field, also it will have some different velocity. Even projectile motion is there, no, therefore, there also velocity components, no, you can take it onto this. Clear? Even kinetic energy means what? Total work power energy lesson, no, total work power energy lesson. How to calculate the kinetic energy, you know it already, right? So, this one, no. And Q into V, therefore, total electrostatics questions, no. So, they may ask you here, no, electrostatics questions, no, where calculating the potential, charge, work done and all this one, no, they may ask you. Here time, this is temperature, no, therefore, total thermal physics, no, so can be involved here, no. Clear? So, in this way, only these simple formulas which are there, no, this many possible ways of questions can be asked onto this one. They may ask you percentage changes, fractional changes. So many different ways the questions can be asked onto this. In this way, you should think. So, therefore, if you think it, no, therefore, the physics will be really wonderful subject onto this, right? Very easily you can see it, right? You understand, no? So, like this, you should learn the physics onto this. Clear? So, let us see some questions, no, related to this one. How you can, I already discussed, no, therefore, how you can solve it, no. So I will give some simple formulas onto this one, so that easy calculation will be there, because H value is 6.6, mass of the electron, charge of the electron, potential, and onto this one, it is slightly complicated, therefore it is already constant. Therefore for electron, this is very important, for electron. Why? Because de Broglie wavelength can be seen for electrons and photons only. Therefore lambda is equals to h by square root of 2 into mass of the electron into charge of the electron into V. So this is h is constant, this all are constant, no? Therefore if you really simplify this one now, so you can write it as like a, so therefore 12.27 divided by root V. Therefore it will give us like in terms of like a Armstrong. Clear? 12.27 by root V. So answer will get in terms of like a Armstrong. Or de Broglie wavelength for an electron, this is for electron only, not for any other particle. Or you can write it as like a 150 divided by V. So this is your Armstrong. This is also one of your easy formula you can remember. Clear? So this is one easy way, so you can remember. So very easily you can solve the problems if you know, if they are accelerated with some potential difference. V is not the velocity, V is nothing but a potential difference. Be careful now. Clear? Not velocity. And answer will get in terms of like Armstrong now. Right? This is for electron. No? Similarly, if for proton, so you can write it as like a, so this is for proton, h by square root of 2 m mass of the proton into charge into V. Mass of the proton is different, no? So you can rewrite it as 0.286 divided by root V in terms of like a Armstrong. This is not that much useful, but I am telling no, only this electron it will be useful onto this. Understand? No? Clear? So even for alpha, you can rewrite it as, for alpha particle, we can rewrite it as wavelength for alpha 0.101 by root V in terms of like a Armstrong. For deuteron, so therefore, so 0.202 divided by root V in Armstrongs. This is here for deuteron, no? So this is for alpha. Note this keep in mind, that's all. So these all are for, in this one, no, I am telling no, these two are very important. Clear? Even so, we can have some more formulas, no? So for you know that de Broglie wavelength depends upon the temperature, no? H by square root of 3m into kT. K is nothing but a Boltzmann constant. So therefore for neutron at particular temperature can be written as like a, so therefore 30.83 divided by root T in terms of like Armstrong. This T should be compulsory in terms of like a Kelvin. Clear? So this is for a neutron now. Understand? No? So neutron, right? This is for electron, proton, right? In all this one now, this is most important now. You may expect the questions on this. Clear? 12.27 divided by root V. These are the slightly some formulas now. Let us do some problems which are involved for this de Broglie wavelength now, right? So very important concept. Let us see now. We will see the question, no, right? Actually, it was not visible properly. That's why I written here, right? Let us see, no. So here de Broglie wavelength of an electron is given as 10 Armstrong, no. So with what potential difference it was accelerated? We want to calculate it now. Very simple question, no. So we know it. Just now we know it, no. We studied here. So therefore 12.27 by root V. Therefore here R we can rewrite it as like one more formula, that is root 150 divided by V in Armstrongs. This wavelength is given as how much now? 10 Armstrong now. So therefore 10 Armstrong cancel here, no? Armstrong cancel here, no? So squaring on this one, no? 100 is equals to, so 150 divided by V, and V is equals to 150 by 100, therefore 15 volts. So this much potential difference should be given for an electron, so that it is going to get a de Broglie wavelength of 10 Armstrongs. Clear? Here also let us write down, no? Here if de Broglie wavelength is there, no, de Broglie wavelength of a moving electron is decreased from 1 Armstrong to 0.5 Armstrong. Okay, so it is decreased from, so therefore here means what will happen now when it is de Broglie wavelength is decreased. See, de Broglie wavelength is decreased means what will happen now? Velocity was increased. That is nothing but a kinetic energy is increased. Clear? So kinetic energy is increased, therefore for this one now kinetic energy is more, for this one now kinetic energy is less. So we want to calculate change in kinetic energy. Also we can add one more question, percentage change in the kinetic energy. So again simple question, when at this point what will be the kinetic energy onto this one? So we can rewrite it as here. Also one more important question, here one more important. Here volt potential difference is given, what will be the kinetic energy of the electron? Kinetic energy of the electron can be written as a very important formula. Kinetic energy of the electron, so you can write down electron volt. Right. So with what potential difference we are accelerated here now? So 15. So therefore it's having kinetic energy is nothing but a 15 electron volt. This is your kinetic energy of your electron. You understand? No? This is applicable for only electrons. Clear? Understood? So kinetic energy in terms of kinetic energy is also can be written as like a electron volt, no? Right? Charge into potential difference. That is the work done. It will be changed in kinetic energy. Here, to gain this one, this much kinetic energy is required. To have this one, this much potential difference is required. So he can rewrite it as same formula. We can use it for 1 angstrom. Therefore wavelength for 1 angstrom. So it can be written as root of 150 divided by wavelength in terms of like a angstrom. Therefore 1 angstrom. So squaring V is equals to 150 volts. So initial kinetic energy is how much now? 150 electron volt. Understood? How you simply written? Clear? So next one therefore for this 0.5 means 1 by 2 into square root of 150 into V in terms of like a angstrom. This also it is angstrom. So get cancel out squaring on this 1 by 4 it is nothing but 150 by V. So V is equals to 150 into 4. So therefore 600 volts. You understand? See here. So to have de Broglie wavelength of 1 angstrom, we require only 150 volts is required. To have de Broglie wavelength of 0.5 angstrom, we require 600 volts. Clear? So therefore, what will be the final kinetic energy here now? Final kinetic energy is nothing but a 600 electron volt of this electron. So he is asking what will be the change in kinetic energy. So change in kinetic energy can be written as kinetic energy final minus kinetic energy initial. Kinetic energy final is how much now? 600 minus 150. So therefore 450 electron volt. This is way you can solve it very easily. Clear? So we can add percentage change in the kinetic energy by kinetic energy initial. This is called fractional change in the kinetic energy. So therefore you can rewrite it as initial is how much now? 150 electron volt. Therefore it is how much now? 3. So fractional change in the kinetic energy is nothing but a 3. Percentage change in the kinetic energy is how much now? Into 100. So therefore what you will get it now? 300%. Percentage change in the kinetic energy can be written as kinetic energy initial into 100. It will be equal to 300%. Clear? So like this you can expect the questions onto this one. Clear? Now let us see. This is slightly lengthier calculations are there. Let us see. So we want to calculate de Broglie wavelength of an electron inside the metal which is at 27 degrees centigrade now. Therefore what will be the temperature now? Then wavelength of the electron it can be written as h by square root of 3m into kT. So right. So here we can rewrite it as 6.6 into 10 to the power of minus 34 divided by root of 3 into mass of the electron is how much now? 9.1 into 10 to the power of minus 31. Boltzmann constant is nothing but 1.38 into 10 to the power of minus 23 into temperature is how much now? 300 Kelvin onto this. Clear? So 300 Kelvin. So simplify. So just mathematical simplification onto this one. You will get it as nearly. Let us see this one. 6.2 into 10 the power of minus 9 meters. This is your de Broglie wavelength of our electron onto this. Clear? So we have to compare this one, no? You have to compare it. So therefore, how much you will get it now? Here at the distance between the two metals, no, it was given like this. So therefore, distance between this one, no, by de Broglie wavelength. So it is given as how much, no? This is 2 into 10 the power of minus 10 divided by 6 into 10 the power of minus 9 nearly. So what I can write it now? Therefore here it will be taken as minus 1 0.2 or 0.2 divided by 6, no? Clear? So therefore here it will be, you can rewrite it as it is 3, therefore 0.1. So 0.033. So you will get your answer on this. Clear? Right? So one important question we will do it, no? Right? So very important question, no? Listen carefully. So we want to calculate the de Broglie wavelengths, right? So very important question. De Broglie wavelength of a proton and alpha particle. So different questions now. Let us see. So for proton, you know the mass of the proton, suppose it is m. So it is having the charge is how much now? E. Alpha particle means helium nuclei. Clear? So mass of this one is nothing but 4 protons, no? So therefore here, 2 protons, 2 neutrons, no? Therefore 4m, mass of the proton and neutron assumed to be equal onto this. So therefore here charge of this one, no, doubly ion in this one, no, therefore 2e. So these are the information is required, no? Now we want to calculate the ratio of their de Broglie wavelength of for proton by alpha in different situations now. First one, if they are moving with the same velocity, same speed, if they are moving with the same speed, what you can write it now? De Broglie wavelength is inversely proportional to v. So that implies de Broglie wavelength of proton by alpha, it is inversely proportional mass of the alpha by mass of the proton. Mass of the alpha is how much now? 4m by, therefore it is m. So it is nothing but a 4. Clear? Suppose next one, very important, if they are moving with the same momentum, this is most important. Most of the students know, they will confuse here. If they are having the same momentum, de Broglie wavelength, how to write it now? De Broglie wavelength, so therefore here it is inversely proportional to the momentum now. Therefore momentum of alpha, momentum of proton, both are same, no? So therefore here it is so for proton by alpha, therefore momentum of your alpha by momentum of your proton, so but same momentum is there, no? Therefore it will be equal to 1. Clear? Very important concept, very important. Next you can rewrite it as, if they are having same kinetic energy, what you can write it now? So de Broglie wavelength is inversely proportional to root of what is the formula here now? Just write down the formula. It will be equal to h by square root of 2m into kinetic energy. So h is same kinetic energy, therefore it is inversely proportional to the mass, no? Same kinetic energy means what will happen now? Therefore de Broglie wavelength is inversely proportional to the root m. Clear? So now what you can write it now? Here de Broglie wavelength of proton by alpha can be written as inversely proportional mass of the alpha by mass of the proton. So mass of the alpha is nothing but 4m by m, therefore it is root 4. You can rewrite it as root 4 value is how much, no? It is nothing but a 2. Clear? Clear? So this way same kinetic energy. Next one they may ask you one more question, no? If they are accelerated with same potential difference, if they are accelerated with the same potential difference, very important. So what is this one now? H by square root of 2m into q into v. So h is same, 2 is same, V is same. Therefore, it is in de Broglie wavelength is inversely proportional to root m and q. So, de Broglie wavelength of proton by alpha can be written as, so mass of the alpha, charge of the alpha by mass of the proton into charge of the proton. Clear? Right. So, what is the mass of the alpha now? Mass of the alpha is nothing but 4m. Charge of the alpha is how much now? Therefore, it is 2e by mass of the proton is m into e. Therefore, this will get cancelled out, no? So, root 8 by 1. Very, very important, no? So, now, so similarly, if this gas is there, like hydrogen gas and all this one, no? All the hydrogen gas and helium gas, so which is maintained at the same temperature. Same temperature. So, same temperature means what you can write it now? De Broglie wavelength is nothing but h by square root of 3m into kT. So, temperature is same, Boltzmann constant is same, h value is same, 3 is same. So, de Broglie wavelength is inversely proportional to root m. That means, so wavelength of the proton by wavelength of the alpha, it is inversely proportional, mass of the alpha by mass of the proton. Clear? So, mass of the alpha is how much now? 4m by it is m. It is nothing but a root 4, it is nothing but a 2. Clear? So, in this way you can solve the problems, right? So, if they are asking about the ratios. Clear? So, this is a slightly important question, no? Right? You can compare it, right? So, which is having more right and less de Broglie wavelength, how they are comparing, very, very important. In this one, no, momentum constant, no, slightly important. Same potential difference is also slightly, right. We will see one simple question, no. So, he is asking wavelength of an electron of an energy is having 100 electron volt. Just now we said, no, kinetic energy, it can be written as like in terms of electron volt, no, it is given as 100 electron volt. So, you can write down E into 100 volts. So, he gave potential difference is how much, no, 100 volts, no. De Broglie wavelength can be written as, so, or you can rewrite it as, so 12.27 divided by root V angstroms. So, 12.27 divided by root 100 angstroms. Therefore, it is 1.227 angstroms. This is your answer. Clear? So, very easily you can solve the problems, no? Right? Now, let us see. Yeah, just now I said, no, therefore, if the velocity of the particle, right, if the velocity of the particle is reduced to 1/3, right, reduced to 2 is given, not right, reduced to 1/3, then the percentage increase in the de Broglie wavelength. That means, velocity, what is happening now? Velocity is decreasing. Velocity is decreasing means definitely compulsory the de Broglie wavelength will be increased onto this. Clear? Clear? So, therefore, you can calculate, so percentage change, percentage increase in the de Broglie wavelength. Therefore, so initial velocity is how much now? It is V. So, final velocity is how much now? 1/3. 1/3 means V by 3. Clear? So, initial de Broglie wavelength, what you can write it now? Therefore, initial de Broglie wavelength, therefore, here it will be h by mv. So, final de Broglie wavelength is nothing but h by m into, therefore, 3mv. Therefore, 3 times of your lambda, first one. Any time percentage means what you have to write it now? Final value minus initial value by initial value into 100. Keep in mind, percentage means you have to write it like this now. Clear? So, for which percentage is asking now? De Broglie wavelength. De Broglie wavelength final, initial by initial. Clear? So, final is how much now? 3 lambda minus lambda by lambda into 100. How much now? Therefore, it is 2 lambda by lambda into 100. So, therefore, it is nothing but a 200% is it increasing onto this. Clear? It's a very simple question, no? Right? Now, let us go for next question. Yeah, this also slightly confusion question will be there. So, but it's very simple question, no? Listen. So there is a here there is a stationary shell of mass 5 m is there now. It is exploded into two parts of masses 2 and 3. So find the ratio of their de Broglie wavelengths. Very simple one now. So initially what is this one now? This is nothing but a 5 m. So therefore initially momentum was 0. Why? Because this is at rest. Clear? Now what happened now? This is exploded into two parts. How much now? It is 2 m and therefore it is 3 m. So initial momentum was 0. This explosion is taken place because of due to internal forces. No, there is no external force acting on this system is 0. So therefore what will happen now? Final momentum also should be equal to 0. That means momentum of this particle should be the same. Yes, sir? Momentum of these two particles, no, it will be the same. Therefore momentum is same means de Broglie wavelength it will be also same. De Broglie wavelength of second one by 1 it will be equal to 1. Understood? Very simple question, no? Clear? So but these simple questions, no, sometimes it will make like a complicated, no. You have to go in a proper right path onto this. Clear? So now let us see here, no, one more question, no, here. Right? So here what happened now? A proton is there, no? A proton is moving in a circular path of a radius. So 6.6 into 10 to the power of minus 3 meters in a perpendicular to the magnetic field of this one now. De Broglie wavelength associated with this one now. See, here magnetism, moving charges. So therefore here in magnetic field, no, if there is a magnetic field is there, if a charge is moving, how it will move now? Magnetic field. So moving charges lesson, no? Therefore here proton is there, is going with one velocity, therefore it will be taking like a one circular path onto this. He is asking what is the radius onto this. Radius. So there not radius, we want to calculate the velocity. With that we have to calculate the de Broglie wavelength. De Broglie wavelength, what is the formula? H by mv. Clear? So velocity we want to calculate, we know the radius is equals to mv by qb. mv already we know it, no? mv is equals to r into q into b. So therefore de Broglie wavelength can be written as h by mv. So therefore h by q into, so b into r. H write it now. Therefore 6.6 into 10 to the power of minus 34 divided by charge is how much now? 1.6 into 10 to the power of minus 19. So 19. So 0.625 into radius is how much now? 6.6 into 10 to the power of minus 3. So 6.6 get cancelled out onto this one, no? So this is how much now? 10 to the power of therefore here this is 22. So 1 by 1.6 into 10 to the power of minus 34 plus 22 by 0.625. You know 1 by 1.6 nothing but 0.625 into 10 to the power of minus, therefore it will be 12 divided by therefore 0.625. This will get cancelled out, no? So therefore here de Broglie wavelength, what you can write it now? 10 to the power of minus 12 meters. Or de Broglie wavelength 0.01 angstroms. Clear? Here therefore it's a very small particle, right? So even though this is going right very great speed also, therefore here it is very very smaller. Clear? Now we will solve one more question, no? Right? We will see one more problem now here. Here a particle of mass m is there, right? So what happened now? It is projected horizontally. That means here there is a mass m is there, it is projected horizontally with a speed it is u. So what will happen now? This will go down like this. After some time, no, it will go down. You understand, no? So here at this point, after some time, no, this is with the horizontal, this is making an angle theta here now. Clear? So therefore here what will be the velocity is there, no? Therefore this velocity v, no? So therefore here you can rewrite it as r. this Vx or this horizontal velocity is not going to change, it is u only, it is a v is the velocity at this point. So what you can write it now, you can just simply you can rewrite it as this component of this one, now you can rewrite it as, therefore v cos theta, it will be equal to u. So velocity at this point, it will be equal to how much now, u by cos theta. You understand, no? Therefore the de Broglie wavelength of associated with this particle at this point, h is equals to h by 2, not 2, therefore it is mv. What is v now? H by m into u, therefore it is cos theta. That is what I said now. Therefore here de Broglie wavelength you can apply anywhere onto this one, like this. Even kinematics equations also you have to apply here. Clear? Some students, they may get the doubt, no, this side velocity, yes, this side velocity combinedly nothing but this is the velocity at this point. Clear? So that is the reason we are taking only this is v. Clear? Now let us see one more question. No? Okay, this is one more problem. No, find the ratio. Right? He is asking, find the ratio of the de Broglie wavelength of a molecule of hydrogen molecule and helium. Right? So here, therefore here what you can write it now, he is asking de Broglie wavelength of hydrogen molecule H2 by therefore helium. So what you can write it now in terms of temperature now. Therefore here it is, you can rewrite it as h by square root of 3mkt. You can rewrite it as, here mass and k and t are both are same, no, therefore de Broglie wavelength is inversely proportional to root m into t. Clear? So therefore here you can rewrite it as, therefore it is inversely proportional root of mass of the helium into therefore helium and temperature of the helium by mass of the hydrogen into therefore here what you can write it now, therefore temperature of your hydrogen. So therefore here mass of the helium is, you can write down 4m, you understand, no, into temperature of the helium. Hydrogen is kept at 27 degrees centigrade, helium is kept at 127. 127 plus 273 is nothing but a 400 Kelvin. No. Therefore it is nothing but a 400 divided by mass of the hydrogen. Mass of the hydrogen is nothing but how much now? So therefore it is 2m, right? So for one hydrogen, one proton, therefore like that 2 hydrogens, no, 2 protons. So therefore temperature of this one is how much now? 300. Therefore it get cancel out now, cancel here now. So therefore here root 16 by 6 or it will be 2 2s. Therefore you can write it as 8 by root 8 by 3. Clear? Like this you can KTG is involved with this one. Like that you have to always try for mixed concepts now, not only one concept, no, you have to try for different mixed concepts. Right, is a very simple question, no, right, which is your so I will tell you, if you are not visible also I will tell you, just right. A particle is dropped from certain height, therefore this is dropped. Dropped means initial velocity is 0. It is dropped from certain height. De Broglie wavelength of the particle is a function of the height. Therefore, when it comes to certain point here or down, no, therefore what will be the velocity? Velocity is a free fall. Is a free fall, right? Free fall means when you are reaching the ground, no, therefore it is nothing but a 2 GH. De Broglie wavelength is nothing but a h by, so m into v, h by square root of therefore here m into square root of 2gh. So de Broglie wavelength is inversely proportional to root h. Clear? Or de Broglie wavelength is proportional to h to the power of minus 1 by 2. So D option will be your correct answer in this one. Clear? Even kinematics equation is involved with a de Broglie's onto this. Clear? Right. So this is one theoretical question, no, very important, right? If anybody is right seeing this video, right, If you really see this question, no, please stop this and answer this one, no, so that right, you can test your level onto this. So very interesting concept, no, right. So here what is happening now, here an electron is moving with a velocity of v is equals to v naught I, and in the magnetic field, there is a magnetic field is there, this one magnetic field is there, so is a perpendicular to this one, no. So and one electron is moving, like this, is entering now, and the de Broglie wavelength as a function of time, will it is increases or decreases or remain same or periodically it will change, or you have to find it now. When electron is entering now, so therefore with a certain velocity here now, v is equals to given as v naught I cap. Electron is going, therefore what will happen now, it will undergo like a circular path onto this. But you try to observe in this one point we studied in moving charges, no, magnetic effects of current. Please, if you did not watch, no, please watch, so that you can get the still more clarity onto this. So for if a charge particle is moving in a magnetic field, so therefore its velocity is going to be remains constant. Why? So work done by the magnetic field, that is nothing but a, so work done by magnetic field, so will be 0. So that means there is no work is done. If work is not done, there is no kinetic energy is changed. So that means kinetic energy will be constant. If kinetic energy is constant, therefore mass will not change onto this one, no, therefore velocity is also constant. Therefore in this one now the velocity is not changing. If the velocity is not changing, what about the de Broglie wavelength, h by mv? Mass is not changing, velocity is not changing, no, de Broglie wavelength will be also remains constant. So therefore option A will be your correct answer onto this. Clear? So very logical question onto this one, no, right? You should be very careful onto this. Clear? Now let us see one more question, no? Yeah, therefore here this is already I discussed, no, but one more time it is given. Let us see now. Therefore a proton, a neutron, right, and electron and alpha particle has the same energy. Energy is same. That means here de Broglie wavelength is nothing but a h by square root of, so therefore here it is 2m into kinetic energy. Clear? So energy is same. Energy is same means what will happen now? Here this energy is same, this is constant, no. De Broglie wavelength is inversely proportional to root m. Clear? No? 9. Now we have to calculate. That means here what are the particles are there? Proton is there, neutron is there, electron is there, alpha particle is there. So you know that mass of the proton, it will be equal to mass of the neutron. Clear? This is one point. Second point, mass of the alpha is very larger because it is 4m compared to mass of the proton and mass of the neutron. Actually generally mass of the neutron is slightly greater, but not that much impact onto this. Among this one now, therefore electron is having very low mass, therefore mass of the electron is very low. So this reverse of this one now, what you have tried it now, among this one now mass of the electron is very less, therefore de Broglie wavelength of the electron is very larger, and then afterwards de Broglie wavelength of proton and equal to the neutron compared to de Broglie wavelength of your alpha. This is your comparison. Clear? So de Broglie wavelength of the electron is greater, therefore here it is given this C option. They are written alpha and like this. Clear? No, this is not the C option. Actually, option is we are not able to see it here. Right? This is your answer actually. So you can check it which point is there now. Right? We'll see one more concept now. Let us see now this one, right. So, this is one of your NEET and JEE main question now, right. Let us see this question, very important, right. Now, an electron of mass m, it is moving with a velocity is v naught in I cap. That means here electron is there, electron charge is how much? No, negative. Therefore, it is moving with a velocity is v is equals to v naught I cap. So, in an electric field, E is equals to, therefore, E naught minus E naught I cap. So, its de Broglie wavelength as a function of the time we want to calculate. First of all, let us understand what is the situation here now. Here electric field, therefore, here along the x axis here now, this is your x axis, right, x axis. Now, what is the electric field here now? Electric field it is along the x axis, no. So, electric field is along the negative x axis, therefore, here it is like this. This is your electric field, that means this side is positive, this side is negative, clear. So, therefore, velocity is going in which direction now? Therefore, it is going in the positive. So, velocity v naught, so it is going in this direction on this, clear. Electron, this electron is going in this direction, clear. So, now therefore, this is your electric field, but this side negative now, therefore, electric field now, it is going to exert the force toward this side. What is the force here now? Force is equals to, therefore, E times of your E. So, it is going to create one acceleration A is equals to E by, therefore, M. In which direction now? Along the velocity direction. So, therefore, in this direction, that means this side is experiencing the force, that means this electron will be start moving greater speed now, right. Why? Because of due to the electric field. Now, what will be the final velocity? Final velocity is nothing but initial velocity. Acceleration is also same direction, velocity is also same direction, do not worry on to this. So, it is v naught plus acceleration is nothing but E into E by m into t, that is nothing but v is equals to u plus at, this is clear. So, both are acting in the same direction, that is nothing but I cap. This is your velocity. So, now what you can write it now? De Broglie wavelength now. So, de Broglie wavelength, so you can rewrite it as here h by m into v is nothing but v naught plus E into t by m. So, v naught taken it out onto this one now, therefore, h by m v naught taken here now 1 plus E into t by m v naught, clear. So, we know that, so here it is given as lambda naught, it is nothing but h by m v naught, this is your lambda naught, clear. So, therefore, here this point you can take it here now. So, de Broglie wavelength it will be equal to, therefore, lambda naught divided by 1 plus E into t by m into v naught, this is your de Broglie wavelength. So, first option will be your correct answer, clear. So, this is nothing but a charges which are moving in the electric field. In this way, you can solve the problems on this, clear, right. Now, let us see some more questions now. Yeah, this is one of your JEE main question now. Same type of question now, but slightly change here, right. So, therefore, here the same type, right. Let us see this one now. Here the electron is moving with V is equals to, therefore, V naught I cap, and electric field is there, no, it is along the j cap, that means here 2 dimensional is there. So, that means here you can rewrite it as here, no, this side it is your x axis, this side it is your y axis. So, therefore, here there will be a electric field is there now, clear. Electric field in which direction now? Plus, and this is minus. Here now what happened now? Now electron is going in which direction now? Electron is going in this direction now, clear, because V I naught, my electric field is in this direction now, it is E, clear. Now what happens now? Here when electron is going toward this side it will be the V naught, but it is going to experience a force here now. Which direction is going to experience a force now? This side is negative, this side is positive. It is going to experience a downward force. That means what will happen now? Here this due to this electric field, it will come down like this. Let us see now. So how it will come down now? So it will come down like this, like our horizontal projectile motion. So it is coming down because of due to the one acceleration. What is that acceleration? Because of due to this force. What is this force now? E into E. So therefore just now we said no, A is equals to E into E by M. Clear? So this is an acceleration. So as a function of time, after some time no, therefore downward velocity was not there. It's like exactly horizontal projectile motion no. So if you don't know, please go through it. I will keep it in the I card here no. So therefore horizontal projectile motion no. Therefore when it is going this side, velocity it will be remain same here V naught I cap no. But downward velocity, we did not provide any velocity when it is going. So because of due to the electric field, it is going downward and downward. Therefore so it is going like this. Clear? Is coming downward. So initially this is here along the J cap now, minus J cap. Clear? So therefore initial velocity along the y axis is nothing but a 0 onto this. Therefore here what will be the final velocity here now? Final velocity along the y, it will be equal to, therefore E into T by M. Clear? So what will be the velocity at this point now? V we can write down V naught I cap plus or plus of this is minus. Why it is minus? Because it is going in negative y direction now. E into T, therefore it is E naught into T divided by M. It is in J cap. So this will be the velocity of the particle now. Clear? Now we can write down the Debroglie wavelength. No? First of all, let us calculate the magnitude. See, Debroglie wavelength, we should not go for vectors. No, we should take it in terms of a magnitude. Magnitude we can take it here now. Magnitude. So V is equals to root of V naught square plus E into E naught into T by M whole square. Clear? So V naught square taken common now. V is equals to V naught root of 1 plus E into E naught into T by M V naught whole square. Clear? So what will be the Debroglie wavelength now? H by M into V naught. This is now V naught 1 plus E naught into T by M into V naught. So therefore what you can write it now? Here it will be equal to H by M V naught. What you can write it now? H by M V naught. So therefore lambda naught by 1 plus E naught into T by M V naught at root whole square. So therefore here whole square, it is a root. This is your Debroglie wavelength. Yeah. E naught E square T square by M V naught square. This is C, it will be your correct answer. Clear? In this way, you have to solve the problems no for this one. No. Listen, right? Now here it is a collisions lesson. Collisions, right? So here, therefore, two particles are there, A and B, of Debroglie wavelengths combined to form like a single particle. That means conservation of momentum. Okay. So that means what will happen now? Suppose it is mass of the particle. So it is going with a velocity V1, U1, and another particle mass M2 going with a velocity is V2. So gives rise to. So therefore what will happen now? Therefore it will be forming like a single particle. No. Therefore it is going with a common velocity. This is M, M1, M2. Clear? This is having Debroglie wavelength lambda 1 is equals to H by M1 U1. This is having Debroglie wavelength H by M2 U2. Clear? So this is having Debroglie wavelength lambda is equals to H by M1 plus M2 into V. Clear? Clear? So, but we know that in the collisions, no, momentum conservation will take place. No, momentum of this one, no, P1 plus P2 is equals to P. So, what you can write it now? Therefore, here H by mv, therefore, here you can write on H by P1, this is H by P2, this is H by P. So, P is equals to, you can write on H by lambda is equals to H by lambda 1 plus H by lambda 2, H taken common, 1 by lambda is equals to 1 by lambda 1 plus 1 by lambda 2, lambda is equals to lambda 1, lambda 2, lambda 2 by lambda 1 plus lambda 2. Clear? So, this is de-Broglie wavelength if the two particles are going in the same direction. Suppose the same question is there, no, if they are going in opposite direction, no. So, therefore, here you should take it as momentum, it will be equal to P1 minus P2 is equals to P. So, therefore, here minus you will get it, no, here minus you will get it, no. Clear? If they are going in the same direction, no, I mean opposite direction, no, you will get it as minus. If they are going in the same direction, it is a plus, no. Therefore, in this way we can solve the problems related to the de-Broglie wavelength, no, right. So, and we can have some more questions, no. Therefore, photon and de-Broglie wavelength, no. Therefore, for the photon we will take it as like a one complete one small video related to the photon, no. Clear? So, now right now for this de-Broglie wavelength, no, this is right final, no, and one more video we will do it, no, or like a special fully IIT advanced level questions, no, we will take it and we will try to combine all the topics, no, we will come with a one more video, no, right. So, thank you for watching. Please subscribe to my channel, no. You can study, you can gain the knowledge from my YouTube channel very easily and freely also, right. Please subscribe and support my channel. Thank you for watching.